Alright, so next we have independent events. Now, if we have independent events, that means that whatever the outcome of the first one is, it doesn't change what the outcome of the second one is. So if I'm thinking about I'm playing two games, whether or not I win my first game has nothing to do with whether or not I'm going to win my second game. So again, we've got a tree diagram, and remember that when you have tree diagrams, you want both of your branches to add up to 1. So if I have a probability of 0.4 here, that means that I have a probability of 0.6 here. Okay, and again, I've got 0.3 here, so 0.7 that she doesn't win. Now, again, we want to read our question and make sure that we get all of the information that we need. Okay, so the probability that she wins at Hoopla is 0.4, whereas the probability that she wins on the Coconut Shy is 0.3. Okay? Now, if we think about it, the probability that she wins at Coconut Shy isn't going to change whether or not she wins at the first one. So, when we did the dependent probability, it changed whether or not it was windy or not windy, right? But whether or not she wins that first game has nothing to do with whether or not she's going to win that second game. So those two branches are going to stay the same. Now, it then wants us to work out the probability that Windy wins at Hoopla and also wins at Coconut Shy. So, what I want to do is I want to multiply the probabilities that she's going to win at Hoopla and also win at Coconut Shy. So, we know she's got a 0.4 chance of winning at Hoopla. So, 0.4 times winning at Coconut Shy, she's got 0.3. So not as good. So I'm going to multiply those two numbers together, and I'm going to get an answer of 0.12. So the probability that she's going to win at both is 0.12 or 12%. Okay. And again, we want to show that we understand that we want to take the probability of winning a 1 and then probability of winning at the other, and then multiply them together to find our independent events. Now, this one, it gives us the two pass rates, and it wants us to work out the probability that both girls fail. So remember that both of your probabilities need to add to 1. Okay, so if I know that there's a 0.6 chance that she's going to pass the test for Lily, I know that there must be a 0.4 chance that she's going to fail it. Okay, and that's going to be Lily. Okay, and then for Anna, it's going to be, again, 1.0 minus 0.8 gives us 0.2. Okay, so I wrote this out a little bit differently, but same thing applies. I'm just saying I'm taking the whole probability minus the probability that she's going to pass, and that gives me the probability that she's going to fail. Now, if both of these girls are going to fail, then I want to do 0.4 times 0.2, which gives me a probability of 0.08. Yeah. Okay, and it is as simple as that. Now for this one, it wants us to work out the probability that both of the girls pass or both of the girls fail. So I want the pass, which we did, the fail, which we did, which was 0.08. And then we want the pass rate, which is going to be 0.6 times 0.8. Which is going to give us 0.48. And then this OR tells us that we need to add those two together. So we're going to have 0.48 plus 0.08, which gives me a probability of 0.56. Oops. Alright, so this isn't actually independent probability, but these are the more complicated higher level conditional probability. So again, this is if I take something out, it affects the next outcome. So when I look at these, it's mostly coming down to, can I figure out what the different outcomes I need are, and can I figure out the probabilities for each one of them. Okay, so if I have 3 types of sweets, I've got mints, toffees, and sherbet lemons. So I'm going to call them M, T, T, and S. Okay, so she takes 3 sweets at random from the bag. Work out the probability of the 3 sweets. Exactly 2 will be the same flavor. So I can have a mint and a toffee. I can have a mint and a sherbet. I can have a toffee and a mint. I can have a toffee and a sherbet. Again, seeing what I'm doing here. And then I can have a sherbet and a mint, and a sherbet and a toffee. Okay, so now that I've figured out what those different ones are, I then need to figure out the probability of each one of those scenarios. So again, remember that each time she takes a sweet out of the bag, that's going to be 1 less than we have. Okay, so we know we have 9, okay, and then 6 gives us 15, and 5 gives us 20. So we're always out of 20. Well, for our first one, we're always out of 20. Okay, and then from there, we're going to go to 19 and 18, okay, as our denominator. So mints, we've got 9 out of 20 times 8 out of 19, because I've taken one of those mints out and one of those candies out, times toffee, we've got 6 out of 18. Okay, that's going to be my first one. Second one, I've got same for the first 2, because I've got 9 out of 20 for the mint, 8 out of 19 for the second one, and then the sherbets, we've got 5 out of 18. Okay, and again, because these are all different events, I'm going to multiply the 3 probabilities together to get my actual probability of that event happening. Okay, toffee, toffee, mint, we're going to have 6 out of 20 times 5 out of 19 times mints, we've got 9 out of 18. And I'm just going to move this one up here so that I have a little more space. So we've got toffee, again, we've got 6 out of 20 times 5 out of 19. And then sherbets, we've got 5 out of 18. And then we've got 5 out of 20 times 4 out of 19 times our mint, which is 9 out of 18. And then we've got 5 out of 20 times 4 out of 19. I don't know what I keep hitting that does that, but it's really annoying. Stop it. 4 out of 19 times 5 out of 18. Okay, so once I've done that, I'm going to plug all those numbers in. So I'm going to do 9 times 8 times 6 gives me 432 out of 20 times 19 times 18 gives me 6,840. Then I'm going to do 9 times 8 times 5, 360 out of 6,840. Then we've got 6 times 5 times 9, 270 out of 6,840. Oops, sorry. And then we've got 6 times 5 times 5, so 30 times 5. 150. 5 times 4, so that's going to be 180. And 5 times 4 times 5, 100. Now, once I have all of those different scenarios and their probability, the last thing I need to do is I need to add all of those together, okay, so that I have the probability that of the 3 sweets, exactly 2 will be the same flavor. So now I'm representing all of these different scenarios that I've found, okay, and adding them all together. So I'm going to have 432 plus 360 plus 270 plus 150 plus 180 plus 100, which gives me an answer of 1492 over 6840. Oh, this thing's really bothering me today, sorry. So 6840, okay, over 1492 over 6840. Okay, again, we want to simplify, so if I do, and I'm going to cheat and use my calculator. And we get an answer of 373 over 1710. And that is our probability. Okay, so because these are more work, they are worth more marks, so you want to make sure that as you're going through, you're showing all of your steps, okay, and clearly marking what you're doing. So if I was marking this, I would maybe not give me the points for adding up all the probabilities together because I didn't show that step. So if I was writing this and it was my GCSE, I would obviously want to go through and write out all of my different fractions and then show how I got that final answer. Okay?